Hello, this is way 25, and it deals with electron configuration. Now, if you recall, if you look on the periodic table, electron configuration is provided for you as digits separated with a hyphen at the bottom left corner of the element on the periodic table. And this represents the ground state configuration. What ground state means is that these electrons are in the bottommost energy levels possible. They are not excited. They haven't moved to higher energy levels. So in this case, carbon has 2 in the first energy level because 2 is the first digit that we see, and 4 in the second energy level because 4 is the last digit that we see. Whenever an electron becomes excited, it absorbs energy, and one of these electrons from these lower energy levels moves to a higher energy level. Now, please note that when this happens, there's no change in the amount of electrons. It simply means that the electron configuration changes such that one of these electrons in either the first or the second jumps to a higher energy level. So questions will frequently give you an electron configuration and ask you to identify which one represents an excited state. Let's try some problems. Which electron configuration represents the electrons of an atom in an excited state? To do problems like this, you first have to know how many electrons we can fit at each energy level. For that, we go to group 18, the last column of the periodic table. This last column shows the maximum number of electrons we can fit at each energy level because these elements have their last shell completely filled. So for example, there are a maximum of 2 electrons in the first, 8 electrons can fit into the second, 8 into the third, 18 in the third, and 8 in the last. So if you look at this group, you can always determine exactly how many we can fit. So using this information, let's see if we can figure out which one of these represents an excited state. Remember, excited simply means that electrons have moved from a lower to a higher energy level. Okay, the answer choice is 2, and here's why. Normally, the ground state configuration of this choice would be 2-3. We can fit a maximum of 8 in the second energy level. But notice, instead of being 2-3, one of these electrons jumped to the third. And now we have 2-2-1. Therefore, the only possible electron configuration that features an excited state is answer choice 2. Both 1, 3, and 4 are possible ground state configurations because we can fit a maximum of 8 in the second energy level. So number 1 isn't quite filled. Let's look at another problem. Which electron configuration represents the electrons in an atom of calcium in an excited state? So you first have to look up calcium on the periodic table to figure out its ground state configuration before you figure out what a possible excited state configuration. Okay, when you look up calcium, you realize that its ground state configuration is 2-8-8-2. Notice the reason why this is excited. Choice 4 represents calcium in an excited state is because the second electron moved to the fourth. So instead of 2-8 in the ground state, we have 2-7, and one of these moved to the fourth energy level. Therefore, answer choice 4 is correct. Which electron configuration represents the electrons of an atom of neon in an excited state? Once again, you need to look up neon on the periodic table and find out its ground state configuration before you decide what the excited state would look like. Neon has an electron configuration of 2-8. So to show excitement of electrons, we simply moved the second electron, the electron in the second energy level to the third. Therefore, the answer choice 3 is correct. Which electron configuration represents the distribution of electrons in a potassium atom in the ground state? For problems like this, you can just simply look up potassium on the periodic table and find its electron configuration, because every electron configuration on the periodic table represents ground state, unexcited. Okay, when we look up potassium, it has 2-8-8-1, therefore the answer choice 1 is correct. For this one, it says which electron configuration represents an excited state for an atom of calcium. When you look up calcium's electron configuration, you'll find that it's 2-8-8-2. So to show an excited state, we move that electron in the third energy level to the fourth. Therefore, answer choice 3 is correct. Remember, the answer choices should have the exact same number of electrons as the element featured in the question. If that number is different, if the sum of the numbers is different, then that cannot be a possible answer choice. Which element has 6 valence electrons each in each of its atoms in the ground state? Valence simply refers to the electrons in the last energy level, the last digit. So for this, all we are simply looking for is an electron configuration whose last digit is 6. Okay, when you do that, you'll find that the only possible answer choice is selenium with a last digit of 6. Therefore, answer choice 1 is correct. Last problem. Which electron configuration represents an atom of chlorine in an excited state? Again, when you look up chlorine, you'll find its electron configuration to be 2-8-7. So to show an excited state, we move an electron in the second energy level to the third. So remember, whenever you need to determine an excited state electron configuration, look up the ground state for that element on the periodic table in the lower left-hand corner. Then, to excite that state, we simply have to move one of the electrons from the lower energy level to a higher one. So make sure that your answer choice matches the number of electrons in the element featured in the question, as well as showing one of the electrons moving to a higher energy level. Hopefully this was helpful, and thank you for watching.